Forward bias characteristic of a semiconductor diode. A very simple experiment. In this experiment, we use a diode and we find out the forward bias characteristic and cut-in voltage. In order to make the connections easier, we connect the diode to a key like this. This is actually the diode. Diode is only this much. So if you purchase a diode in the shop, it will be like this way only. It will be like a cylindrical structure with P and N sides inside. That semiconductors will be inside. Now we make the connections easier, we connect two terminals to the two ends of the diode. So we have connected P side to the red terminal and N side of the diode to the black terminal, so that identification will be easier. But actual diode is only this one. So we use this whole arrangement and we connect it. And the circuit is very simple. We have a battery. Against the battery, we connect a rheostat here. The positive of the battery is connected to one end of the rheostat. Negative of the battery is connected to another end of the rheostat. Variable end of the rheostat is here. So the two ends of the rheostat are connected to the positive and negative terms of the battery. Now, the end of the rheostat which has received positive from the battery. So this positive end comes here. From the same end, you connect it to the positive of the milliammeter. Negative of the milliammeter is connected to the P side of the diode. The N side of the diode is connected to the variable end. So this is variable terminal of the rheostat. Then across the diode. So from the end of the rheostat where we have received positive of the battery, from the same end positive of the milliammeter and negative of the milliammeter to the P side of the diode, negative of the diode, N region of the diode to the variable end of the rheostat, and the voltmeter is connected across the diode with this positive terminal to P side, negative terminal to N side. That is to record the voltage across the diode. So very simple circuit. You can see the circuit here also. Yeah, this one. So here you can see a battery. The positive and negative terminals of the battery are connected to the two ends of the rheostat here, and the variable end of the rheostat is here. So from the end where we have received positive, connected to the positive of the milliammeter, negative of the milliammeter to the diode, from the N side of the diode, the variable end here. So here you have a jump like this. Now across the diode, there is a voltmeter like this. So very simple circuit. So this is the diode actually. Okay. So here in milliammeter, you will be given a milliammeter of multiple range. So you will have the readings like this. Here you see, this is red one. This is common, positive. You must use it. So that should be used. Now out of the negatives, you can use any one. How to choose the one? Depending on the range that you are going to select. So here in our experiment, the maximum current that we are going to record is 30 milliamperes, 35 milliamperes. So you can use the range 0 to 50 milliamperes. How to make the 0 to 50 milliamperes range? So positive is common. Negative, either you can select these two. So positive and this one. I think you can see 500 written here. So if you select this, then you are selecting 500 range. If you select positive and this 50 terminal, you can see 50 written here. Then you are using 50 milliampere range. If you are using this, that is 5 actually written here. This and this one and this one, common. Then it is 5 milliampere range. So all the readings are in milliamperes because it is written here. See, milliamperes, and the straight line indicates that it is DC current. So it is DC milliamperes. Millimeter. Now, what is the difference if you are using 0 to, so this is common. If you are using these two, then you have to choose this scale, 500, 400, 300, 200, 100, 0. Because maximum is 500, range is 500. So if this is 100, the difference is you have 10 divisions here. Each division will be 10, 0, 10 milliampere, 20, 30, 40, 50, 60, 70, 80, 90, 100. 110, 120, this will be 150, this will be 200, 300, 350, 400, it will be like that. So that is when you are using 0 and 500 scale. Now the range of the ammeter will be maximum, but every reading, that every division will have more value. So when the needle comes from here to here, it will be 10 milliamperes jump. So you can't measure 1, 2, 3, 4, 5 milliamperes, because by the time it reaches here, it will be 100 milliamperes. This will be 10, 20, 30, 40, 50. So you can't measure 12, you can't measure 13. So you can't measure minor values, but range will be more. Instead, if you are using, instead of 500, suppose I use this and 50. So we will be using this range. So 0 and 50. So connect the positive of the millimeter here, negative of the millimeter here. Then what is the change here? Now you have to select this range, 0, 10, 20, 30, 40. You have to take the readings here. You can't take the readings now in 100, 200, 300, 400, 500. Now the maximum range is 50 itself. So maximum is 50. Now this is 0, this is 10. So in between you will have 0, 1, 2, 3, 4, 5. This will be 10, this will be 20, this will be 30, this will be 40, this will be 50. So you can get the values like 11, 12, so even single digits also, not from directly 10 to 20. So 1, 2, 3, 4, 5 is also possible, 25 is possible, 26 is possible, 30 is possible, 32 is possible. So you can get all the values between 30 and 40, all the digital unit values, 31, 32, 33, like that. So that is the use of connecting it to 50. So usually we will be connecting 0 to 50 range. Suppose you use, of course, we don't have that application. What is the use of this 0 to 5? So when you are using 0 to 5, remember, you are getting only 1 milliampere at the maximum. But you can measure very small values also. That is the advantage. So when you choose a large scale, when you are choosing this one, you can measure up to 500 milliamperes. But the minimum possible value is 0 to 10, 20, 30. So 10 difference. When you are using 0 to 5, so if I am using this and this, positive here, negative here, then the advantage is I can have 5 milliamperes. So I have to take this reading 1, 2, 3, 4, 5. Then this becomes 0.1. I can measure even 0.1. Last time I was able to measure when I was using here only up to 1 milliampere, 2 milliampere, 3 milliampere. I was not able to measure 1.1. So here 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1 milliampere. This is 2, this is 3. So it will be this range. So according to the terminal that you choose, you will have the range different. When you are selecting a large range, you can measure a large current in milliamperes, but the range of values will be larger, but you can't measure very small values. When you select the smaller value, you can measure the very, very small values. Accuracy will be more, but you can't go for a large range. So one has one advantage, another disadvantage. Okay, so you must know which range you are going to select. So here we are going to select 0 to 50. Because in our forward bias characteristic experiment, maximum current recorded is 30, 35. So we will connect this and this, plus here, minus here. Then the scale chosen is 10, 20, 30, 40, 50. And if the needle stands here, then it is 6. And if the needle stands here, then it is 14. Needle stands here, then it is 39. Because this will be 0, this will be 5, this will be 10, 15, 20, like this. So we have such ammeters, millimeters, like this. So here this is common, and you can use this 50 milliampere range. It is kept open, and these two are not supposed to be used. They should be kept open. So you can choose the scale 0, 10, 20, 30, 40, 50. So each division will be 1 milliampere. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that. So this is another type, similar type. You can use 50, 500, 0. Okay, so this is the circuit, and you will connect the diode and record different voltages and currents, and the range of values, better you know them. You can set the current and find out the voltage also. So after some certain current, the voltage almost remains the same. Then draw the graph. Voltage along x-axis, current in milliampere along y-axis. Once you draw the graph and you have to join it to 0, so after some voltages, the current increases sharply. So almost from here to here, it is almost a straight line. Even from here, you can choose it, no problem. So find out from which voltage along x-axis the current has increased linearly, very sharply. That voltage is called cut-in voltage. Here, I think it is some 0.26 volt. So the voltage after which the graph is almost a straight line, here or here. Small difference will not make any change in the marks, no problem. You can almost find out that cut-in voltage. So that is the forward bias characteristic of a diode, and finding the cut-in voltage, the voltage after which current rises sharply and current is almost proportional to voltage. Thank you.